going to be talking about insulation and some products that we have found over the last year or so. But I'm going to be honest, this is actually the second time we're recording this. We ran some insulation tests a few months ago and recorded a whole video all about it, and it finally happened after 2 years of this channel. We actually lost that video. So we've searched everywhere, couldn't find it, so I'm going to do my very best to try and remember everything that we talked about last time and give you all the information about what we have found on some different insulation products and some tests that we've done. So a couple of years ago, or maybe a year and a half ago, we recorded a video about insulation. It was about a product called Roxul, which has now rebranded and their name is just called Rockwool. And this is it right here. We used 1.5 inch, it's called Acoustical Fire Bat Rockwool. And back at that time, we still didn't completely know the scope of this renovation. So we were just insulating the sidewalls of the bus. We had thought that we were maybe gonna leave the original, the original ceiling with the original insulation up in there and just clad over that. Well, at some point, there was actually some of that original insulation up kind of in the ceiling space of one of the bays, and Juan was in that bay doing some work with the angle grinder, and a spark hit that original insulation and caught it on fire, and he had to grab it and throw it into the driveway, and we literally sat there and watched it burn on fire for about 5-10 minutes before it finally smoldered out. That was the end of the ceiling, the original ceiling in the bus. We said no more. We ripped down that ceiling, pulled out all of that insulation, so there is no longer a speck of that insulation in the bus, thank goodness. But so we knew we had more insulation to do, but we put the inside insulation a little bit on hold because we wanted to do some other projects. But the reason why we picked this insulation to begin with was for a few different reasons. Number one, it is non-combustible even when exposed to direct fire. It doesn't produce any toxic fumes. It is mold resistant. It doesn't have any kind of off-gassing. It's supposed to be sag-free, like it's not going to sag over time. And it's just really nice and easy to work with. Everything in our bus is curved, and so having something that's kind of easy to maneuver and get into all the curves is really nice to work with. It has a really good insulating property, and so good R values, and so we've been really happy with this product. There were other insulations that are pretty common that we looked into, like spray foam, which is a great insulator. A lot of people use it in their bus conversions and are super happy with it. There was just a couple reasons why we didn't. Number one, the off-gassing, it's messy, but the off-gassing will go away. The messiness can be cleaned up. But one of the big things is, as you guys know, if you've been here a while, we change our plans quite frequently, and once you do that spray foam insulation, it's really hard to go back and kind of make changes if you need to add another cable somewhere, run a wire somewhere where now you have insulation. And we've also heard of, as it expands, it heats up, and on our aluminum bus, we've seen examples of that where it actually will bubble out or even crack your aluminum skin as it expands out and produces heat. So that was kind of the reasons why we opted out of spray foam, even though it's a great product. Also, there's foam boards, both the polyiso or the expanded polystyrene, and again, those are good insulators. One of the things with that for us was cost. Also, just again, everything is square and with those boards, and this is just a little bit easier to work with all the curves. So those are some of the other products that we looked into that are pretty common, and we just think this is a great product, and so we've been really happy with that. Okay, so we put the interior of the bus, the build out, on hold during the past year or so while we worked on the electrical and the solar and the paint and the lights and about a million other projects. But during that time, we kept hearing in the bus conversion world about this product called Engine Heat Protection Roll Board, or EHP. So Engine Heat Protection is a company that offers a lot of different insulating products for industrial uses. But this one is called Roll Board, and it's a ceramic, almost like paper-like material, and it's 1/8 of an inch thick, and supposedly it's used in a lot of high-end motorhomes and high-end bus conversions. And there's some people in our community that have used it in their bus and just love it and say it made a night and day difference in really cold climates and hot climates, and they just added it to their existing insulation, and they've been really happy with it. So we thought it'd be worth investigating, because insulation is probably the #1 factor as to how comfortable you are in your motorhome. And so we're willing to spend some extra money if it's going to bring us a lot of value. So at only 1/8 of an inch thick, we thought, we do have just, a teeny enough gap in our insulation space in our walls that we could fit a product like this with our Roxul, and we wouldn't have to like squash down. You don't want to squish this. So we thought it'd be at least worth investigating. And so this is made for sort of the industrial sector to insulate stoves and furnaces and exhaust parts and engine parts and all of that. So it's really, really high heat tolerant and non-combustible and all of those things. It's super easy to work with, but it is rather expensive. This is $2.25 a square foot. To contrast that, the rockwool was only about 40 cents a square foot. So it would be quite an investment to get this. So we thought somebody else has to make the same or similar product in that space, in that kind of industrial space. So we started researching around, and we actually did find what appeared to be a very similar product called Ceratex, and that's it right there. Their website gives a lot more technical details. The EHP website really doesn't give any of the technical data in terms of K values or R values or any of that kind of stuff. Whereas the website, it's actually called MinSeal, I think it's minseal.com, which we'll have links for all of that. They have all the technical detail on this. So on first glance on the websites and kind of knowing what the products are used for, they seem like they were super similar products, but the Ceratex was less than half the cost of the EHP. And so we thought, it's worth investigating at least. So we wanted to know, #1, is it worth it? Are we going to get enough additional insulating properties to what we already have to make spending extra money worth it? So that's kind of #1. And also, is there really any difference in how these two different materials perform? So we thought it'd be really fun to order some samples of each and set up an experiment with our 2 oldest kids. We've been studying physics and chemistry this year with some of our kids in science, and so studying heat transfer has been something we've been working on, and studying the 3 different ways that heat transfer through radiation and conduction and convection. And so we thought this would be a great opportunity for them to design their own experiment and kind of get a practical, real world look at, how, like, you're not just doing a science project for a science fair. Like, this is real world application. You can do this on your own whenever you want to. It's fun. And so we decided what were the things that we really need to know. I mean, what we need to know is, in order to know if it is providing any insulation, is how long does it take for heat to transfer through this product? Okay, how can we measure heat transfer through these materials? And we want to test in both a hot environment and a cold environment. And we need to measure temperature change, and we need to calculate the time that it takes for these temperature changes to happen. And so our 2 oldest kids sat down with us, and we planned it all out. They came up with their hypothesis saying, if it's a better insulator, the better the insulator it is, the longer amount of time it should take for the temperature to raise to a higher temperature or drop lower to a lower temperature in the cold environment. And so they made all of their objectives and their hypothesis. They set up the scope of the test, planned out all the different steps that we would need to take. What would the controls be? What are the variables? Now, obviously in a home environment, we're not in a sealed up laboratory, so we can't account for every single tiny little variable, but we're not looking for precision numbers here. We're really just looking for the comparison in times, and that that is something that we can measure. And so what we did is we bought this little temperature data logger, and it's just USB, and we decided we needed, one of the things that's important in science is that tests are repeatable to make sure that you're getting similar outcomes each time. And so we decided to run each step of our experiment 3 times. So with each new layer or new part of the test, we would run it 3 times in our freezer, measuring the time it would take to go from room temperature down to 0 degrees Fahrenheit. Or in the oven, the lowest our oven will go is 170 degrees Fahrenheit. So the amount of time it would take the temperature logger to go from room temperature up to 170 degrees Fahrenheit. And then when the test was done, we just plug this in, get all the data off of it, plug it into a chart, log it all, track it all, and compare it all. So the first thing we did was, as our control, was put just the temperature logger in the freezer by itself and measured the time it took to get down to 0, just this by itself in the freezer. Did that 3 times. Then we put this by itself in the oven and measured the time it took to get to 170 degrees 3 times. Each time making sure the temperature logger gets back to room temperature before we restart the test. Then we needed an environment to put all of these things in. So we used a cardboard box, and so then that sort of becomes the second part of our control, because we need to eliminate that information just so we're just tracking the information of our individual materials. And so we would put the temperature logger in the box, seal that all up, put it in the freezer. Again, run that test 3 times in the freezer, each time bringing it back to room temperature, measuring the time it took to get down to 0, same thing in the oven 3 times, all that same thing. For each step, that's what we did. So surprisingly, the cardboard did pretty significantly well insulating the little data logger compared to just the data logger alone. It was a good insulator, surprisingly. So the next step was to do each one of these individually. So we made a whole little origami piece of this, cut it out so we could fold it all in on itself. It had a bottom and a top and sides and little tabs, so all the little corners were covered. And so we tried to seal them as best as we could, but the most important thing is that they were identical to one another when we tested them. So we did the Ceratex lining the inside of the cardboard box with the data logger inside, ran those series of tests, took that out, put our exactly identical piece of EHP in there, same thing, sealed it all up, ran those tests in the freezer and the oven, and then at least we had something to compare the two. How long did each of these products take to hit 0 in the freezer or 170 in the oven, running each of those 3 times? And they were comparable to each other, but the edge actually went to the Ceratex. It performed slightly better than the EHP. They were real close, but the Ceratex actually did a little bit better in our tests. And so we thought, okay, if we're gonna use anything, we'll pick the Ceratex. It performed a little better and it's cheaper, so that's kind of a no-brainer. EHP is still a great product, but for the price, we can get a similar, slightly better working product, less than half the price. So now the question became, do we even want to use it at all? Is it going to provide enough of a benefit over just the Roxul alone to make it worth investing any money at all into an additional layer of insulation? So we filled the box with Roxul, put the data logger inside, ran tests with just the Roxul in the cardboard, both the same thing, both the freezer, both and the oven, 3 times each, tracking the time it took for those temperatures to change. Then that was kind of our new baseline. Then, since we had already at that point decided on, okay, if we're going to use anything, it's going to be Ceratex, then we put the Ceratex with the Roxul, put it all together, put the data logger inside to see, does this take a significantly longer amount of time to get hot or get cold, the data logger to get hot or cold with the 2 products working together. And we were really happy to report that it actually did. It performed significantly better than just the Roxul alone. So the Roxul alone performed better, obviously, than either of these 2 alone. Just, I mean, it's an 1.5 inches thick compared to an 1/8 of an inch thick. So of course this is going to perform better. It performed really well. We were happy about. But adding the 2 together added, I think, like we decided maybe about another 25% in the amount of time it took to hit those high and low temperatures. So money and, you know, deciding where to spend our money is always, you know, a huge part of this project. And insulation is just one of those places where you kind of have to be willing to spend some money. If it's worth it, I mean, that's where your comfort level in your motorhome is going to come from. A huge portion of it is insulation. And so we decided for us it would be worth it to spend a little extra money to get that 25% extra in insulation value for our bus. And so that's kind of where we've landed, is that we're going to go ahead and spend the money and buy some of this Ceratex. Okay, so after we decided that yes, we are going to use Ceratex and kind of add that to our insulation arsenal, we called Minseal, the company that sells this stuff, and talked to them about purchasing it. And the nice thing is their company is down in Tucson, only about an 1.5 hour drive from us. So we were able to actually just drive down there and pick it up and save ourselves about $100 or so, maybe 100, I don't know, more than that, $100, $150 in shipping. And so that was great. And then because we bought like 3 big boxes of it, they actually gave us an additional discount on top of that just for buying so much. So so we actually got it for, I think, what ended up being about 35% of if we had bought the same amount and had shipping and all of that stuff on the EHP. So we were kind of nicely surprised at that they gave us a discount and everything, and then we didn't have to pay shipping as well. So that was great. I do want to tell you guys though that this was all a few months ago when we did all of this, when we bought all of this, and even in the last couple of months we have learned so much more about insulation through another channel by a guy named Greg Virgoe. If you guys are not following him and the van build he did, it's a Mercedes Sprinter van, go find his channel, we'll link it. He's a super smart guy, and this is what he does for a living, or what he did for a living, is he insulated like big buildings and all of this stuff. And so he knows all the math and the science and everything behind it, and he has 3 different videos on insulation. One just came out this past week where he did a whole workshop on all the science behind insulating a van specifically, but all these concepts apply across the board here. And he talks about, what does an R value really mean? What is a K value? How does all the heat transfer happen? What about condensation? Where does reflectix, which is kind of a popular thing that comes up in a lot of motorhome builds and RV builds, where does that play into all of this? And so I would really suggest you guys hop on over to his channel. We'll link some of those videos below and learn all you want about insulation, because he's the guy to teach you. kind of funny enough, afterwards we thought, well, turns out K value is really the number you need to know, more so even than R value. That's really the important number to know. So we went back, we'd already bought this and decided on all this, and we went back and said, I wonder what the K values are on the products that we're using. And funny enough, the Ceratex K value and the mineral wool K value are very similar, which tells us that we probably could have just gotten a little bit thicker. Like if we could have found a rock wool that happened to just be 1/8 of an inch thicker than what it is, we would have kind of been the same, because their K values are the same. Now they don't make a rock wool that is 1 5/8. It's kind of either 1 1/2, or then it jumps up to like 2 1/2 or 3, or thicker bats of this stuff. But all in all, we're still really happy with our choices. But if you want to know all about insulation, you've got to go watch Greg's videos on his channel. They're fantastic. You'll learn so much. But we're going to go ahead and get started on putting in this Ceratex.